Hi everyone, welcome to lecture 3 Fourier integral. So here we will solve an interesting problem and represent the function into Fourier integral form. So let's see what is the problem. The problem is find the Fourier integral representation of the function f of x, where the value of f of x is 1 when mod x less than 1, 0 when mod x greater than 1. So how to solve? Let us see. Is how to represent the function. So first step to solve the problem is see whether the function is odd or even, because depending on the odd or even of the function we have to apply Fourier sine integral or Fourier cosine integral. So we'll see first. So how to check? When x equal to minus x, means put x equal to minus x on the function, then f of minus x will be what? F of minus x will be 1, okay? Because if I take in place of x minus x, so same thing mod x, so mod x less than 1 is 1, so 1. So here we can take minus, so minus x greater than 1, which is 1 for mod x less than 1, 0 when mod x greater than 1. So like that we can get. So what is this? This is again f of x. So we saw that f of minus x is f of x. So if that happens, then we say that f of x is even. So if f of x is even, then what we do? Then we get Fourier cosine integral. So we'll write Fourier cosine integral representation of f of x is f of x equal to 0 to infinity aw cos wx dw. Now what is aw? aw is 2 by pi, okay, 0 to infinity f of v cos wv dv. Now if we put aw here in f of x, then finally the expansion or the full expression is 2 by pi integration 0 to infinity, another integration 0 to infinity, okay, then f of v cos wv into this one cos wx dv dw. Now we'll see then what will happen. So f of x will be again 2 by pi 0 to infinity. Now here if you see the factor cos wx, in cos wx there will be no v term or no v variable. If there will be no v variable, we can bring this to the left. So what will happen? So 2 by pi integration 0 to infinity cos wx, then integration 0 to infinity f of v, then cos what? wv dv dw. Okay, now clear. Next thing is that we have to replace the function value by seeing the problem function. The problem function is given f of x is 1 when mod x less than 1, 0 when mod x greater than 1. We will see. So these two expressions are important, that is mod x less than 1. So if we take mod x less than 1, that means what? This we can write it as plus minus x less than 1, or simply x less than 1, and another expression is minus x less than 1. If we multiply minus 1 both the side here, so it will be x greater than what? Minus 1. Okay. So what will happen? Now we get -1 less than x less than 1. So for first x domain. The second domain, what? Mod x greater than 1. So this we can write it as plus minus x greater than 1 or x greater than 1, first expression. Okay. And second expression is what? Minus x greater than 1 or simply x less than -1. Okay, so if we see the number line, so this is 0, -1, 1, then what will happen? So for first domain, okay, x lies between what? -1 to 1. But for the second domain, x will be what? Less than -1 and greater than 1. So this one will get. Now we'll apply this domain and find the function value and replace here. So we know our integration defined over 0 to infinity. So 0 to infinity means which one will come? So first one, okay. So first one, 0 to 1 value is 1, but after 1 value is 0. So the integration will write it as this 2 by pi times 0 to infinity cos wx, and this 0 to infinity will now becomes 0 to 1 because after 1 the value function value is 0. So 0 to 1, 1 into cos wv dv dw. Now what we will do, we will solve this part, v part or dv part. So if we solve, we will get what? 2 by pi 0 to infinity cos wx. Now here cos wv. So integration of cos wv will be what? Sin wv by w. Okay, from 0 to 1 dw. Now 2 by pi 0 to infinity cos wx into, so if I put v equal to 1, so sin wv by w. If I put 0 in place of v, so sin wv will be 0, so total will be 0. So finally we will write what? Sin wv by w dw. So finally what we obtain? We obtain f of x equal to 2 by pi times 0 to infinity integration cos wx sin w, okay, by w dw. Or if we take 2 by pi to left, so what will happen? This integration 0 to infinity cos wx sin w divided by w dw equal to pi by 2 times f of x. But what is pi by 2 times f of x? So it will be pi by 2 when mod x what? Less than 1, and pi by 2 into 0, so it will be 0. So 0 when mod x greater than 1. So this is our answer. So in this way we can represent a function into Fourier cosine integral form. So I request you all collect some problems on Fourier cosine integral and solve it. If you find any doubt, difficulty, or if you get any idea to solve the problems, then please comment in the comment box or mention in the comment box. I will read all these comments and reply.